I'll ask you if we are ready to begin. Prince, sir, I hope you can hear me.
Yes, Deepak, very much. I can hear you.
Okay, perfect. So, hey everyone, welcome all of you. Let's do one thing before as always, let's do the most, I would say, looked forward part of the session where we discuss about the previous old scores. And today we have a couple of new names. Let's see who they are. All right, let me share my screen before we start. Okay, yes, there we go. Perfect. So the previous session winners are basically Sai Kumar Kaithi, Kartavya Baluja, Safura Khan, Jyoti Kumari, Roshan. Okay, that sounds very similar to Rishan. Lakshita Panuganti, Varalakshmi Chandrasekhar. Guys, congratulations. Your score was 8 to 10, which was basically the highest compared to all other participants. And yeah, kudos to you. And also, a lot of effort has been put in the polls, and we see in the responses many people have scored 7 6. So we just try to take the top score and we show it. But guys, remember that we all are closely watching your poll scores and will be tracking it while giving the certification and also the rewards that we have at the end of module 2. So once again, congratulations all of you, amazing job, great few. And guys, remember that participation is more important, and just you don't avoid these polls, be part of the sessions and also the quizzes and assignments that come in the end. All right, let me ask my, uh, all right, yeah. Let me ask Christian R to, let's begin the session. And yeah, we are waiting eagerly to hear from you, Rishin, and I'm sure the students are equally excited for this session as well.
So am I audible? Am I audible, Deepak?
Yeah, Rishin, you are. Please go.
Okay, good. I'll share the screen. Okay.
Yeah, we can see this.
So guys, welcome everyone to the penultimate session of Introduction to Rust Programming. We have come a bit too far, and we have discussed the basics. We have come to some of the implementations and fundamentals of Rust. And today we'll be discussing two more advanced or good level to know how that you need to have in order to program most of the programs in Rust. Okay. So we'll be discussing about collections and how to do error handling in Rust. So error handling, as you might know, is one of the most important part of programming that any language usually offers. And in Rust, you have a very different methods to actually see errors, to create your custom error, to have unrecoverable and recoverable, two different kinds of errors, how to create errors, and that is all that we will be discussing in today's session. Okay, so we'll go move ahead. Yeah, so initially I'd like to start the discussion with talking about collections. So what is collections? Collections is a particular data structure that allows us to have multiple values. Okay, so multiple values can be added. It includes vector, strings, hash map, etc. Okay, so collections are stored in heap and the amount of data need not be known at compile time. This is the most important use case of collections. Okay, but you cannot consider array as a collection. The reason is arrays need to be initially set, right? The compile time, you need to actually place the size before actually defining an array. So you actually do not place the memory for an array into the consideration during execution. We will be doing all those steps during compilation. Now, collections are stored in heap, and choosing appropriate collection is the most wanted skill that we require And a collection or a particular data structure is chosen based upon two different factors, and that is time and then space it occupies. So if you are considering or you're more likely to reduce time, then we will be more interested in data structures like hash map, which can actually have a time complexity of 1 for retrieval of data. And whereas if you want to reduce space, then we would be considering of different data structures, etc. Okay, so two different considerations are taken into consideration, that is time and space. Okay, so we'll be discussing about vector, string, and hash map. Now we'll go to a small polls regarding the collection stuff that has been discussed till now. So I'm going to launch. Okay, today we have around 5 polls, and I'm launching the first poll. So the first question is: collections can contain only a single value. Okay, so straight true or false. So the options are true and false. The second question is: collections are stored in option A stack, option B heap, option C both A and B, and option D none of the above. I think these are two pretty easy questions. You'll be given a minute and 30 seconds to answer all these questions. So make sure you do it fast.
All right, so guys, so mistakenly I clicked, Rishan, just FYI, I clicked on end poll. So let me do this, that let me relaunch the poll. Rishan, I'm audible, right?
Yeah, you're audible. I think
Yeah, yeah,
I just can't see the timer, and now you have mentioned it. Okay.
yeah. So it's okay. What we'll do is we'll just relaunch the poll.
Okay.
And guys, remember that you have to vote again. Okay. I mean, you have to put in your queries again. Yeah. Guys, remember that you have to put your answers once again. Please do.
So guys, I'm going to end the poll. It's 1 minute 30 seconds. I'll share the results with you. So the first question was: state true or false. Collections can contain only a single value. The answer is false, and 77% got it right. Collections are stored in. The options were stack, heap, both A and B, and none of the above. The answer is heap. As we have discussed before, collections are stored in heap because their size is actually set during execution time. Okay, so stop sharing. We'll go back to the content. So the first data structure or the collection that we are discussing here is vectors. Okay, now what is a vector? So the basic definition for a vector is a dynamic array. That means an array whose size can be changed at any point of execution. Okay, during the program execution, you can change the size of the dynamic array or vector. So vectors allow us to store multiple values of the same data type similar to an array, but it can grow. Now it can be referred as dynamically growing array. Now how do you create a vector? So this is how you create a vector. You need to place let v and then you need to place the data type. The data type is vec i32 for i32 data typed vector. Okay, so you can place vec new. This is one way of creating the vector, that is using the vec new, or else you can use the vec macro. Okay, just we'll see the example so that it will be more easy to understand. So this is the case. So you have two methods to create a vector. The first method is using the vec new function, that is by using vec colon new, so that it creates a new object instantiation of the object vec, and then we specify the data type here, that is vec i32, so that the vector shall only contain elements of the type y32. Okay, so if you try to push a data of data type float or string into the vec, then it would generate an error. Now we have the other method. This is one of the easiest method to create a vector, is to create like let v equal to vec. This is a macro. This is a vec macro, and then you can specify the elements inside this vec macro. Okay, so that is one other method. Now these vectors are by default created, and then you may not change its contents. Okay, because this is actually set as immutable by default. As we have discussed, a variable or any kind of data structure that is initially created would be by default immutable. So if you want to enter values into a vector, then you will instantiate it as let mute v, so that we can push in values into the vector. Now there are two operations that you can do into a vector, that is push and pop. Push means you are inserting value, pop means you are taking out values. Okay, so I have created let mute v, which is vector new. So I've created a new instance of the vector, and then I'm using the push function. So v dot push 5. So anything that is passed into the push function will be inserted into the vector. Okay, so now I have passed 5, 6, 7, and 8. Okay, so my vector would be containing 5, 6, 7, 8 in straight line. Now the second, so yeah, how to access the elements from a vector. So these things are pretty much simple. You just try to understand this and then go try out, do more examples so that you get a good idea. You can have a vector of structs. Okay, you can have a vector of any data type. So if you create a struct and you want a vector of structs, even that is possible. Just in the place of i32, you need to place the struct name. Okay. Now the second element is, yeah, I am trying to access the secondary, similar to accessing an element from an array using v1. V1 means access the index 1th element. Okay, so here I think the index 1 should be 6, because vectors also start from index 0. So index 1 should be 6, and this would produce an output 6. Okay. Now, what about you can access it using the get function also. Now, the use case of get function, see why we would want to use the get function rather than using a normal indexing method to access an element. Okay, so the get function actually works using the enum option. So if you try to pass a valid index, then it would give you a sum of x. So sum of x means it will give you a sum value. What if you're trying to pass an invalid index like -1? So -1, you cannot access an element of -1 index, right? Or else what if you have a empty vector and you're trying to access the third element? That is also impossible, right? So in these cases, when you use the v dot get, you need to actually match the corresponding variable or like match v dot get, so that if it is a valid index, then it will return a sum of x. So we can print ln the third element is x, or else we can actually create a none. So none means it is an invalid index. So if you are using the v dot get function and you're actually assigning let third element equal to v dot get to 2, that means you are not getting the required value. Rather, you might get a sum or you might get a none according to the index that has been specified. So if it is a valid index, then you would get a sum of x, and to retrieve x from the sum of x, you need to use a match statement. So you'll match the value against sum of x and none. Okay. I think the idea is clear because we have discussed about these things in the previous session. So it should be easy. Okay. So that is all about the matching. And this is one of the safest method to actually try accessing an element from a vector. Okay. Now, how to iterate? Iterate is like literally similar to how you would iterate in Python. Like you can do for I in V, you can just print I. So these are the easiest and the most simplest operations you can do with vector. It's just simple. As you can see, we just need to create or instantiate a vector by using two methods. We have two methods. You can use a vec new or the vec macro, and you can instantiate it as mutable so that you can add elements into it or remove elements from it. And the push function is used to actually add element. Pop is used to pop element. Okay. Now you can access it using the normal array kind of accessing or a safer method, that is the get function. And you need to pass the index in the get function. And you can, if you are passing the get function, then you need to use a match function in order to match the sum value and the none value. Okay, so that we can get the right answer. Now the normal iteration or iterating or traversing through the vector would be simple. That is, for I in V, you can just print it. Okay, I think the idea is clear. Now try executing this program once so that we can see all the outputs that we have discussed till now. Okay. Now, proceed. Right. So there is no error. Okay. So let's go back so that we will see the outputs. Yeah. So initially we created a mute vec and then we tried to access the second element. The second element was 6, right? Because we passed 5, 6, 7, 8, and the second element is 6. The third element is 7. That is the output that we get. Why? Because we tried to pass a valid index 2. What if I pass the 10th index? What if I pass index 10? Actually, I do not even have 10 elements in my vector. Alright. I'm going to execute it again. I'm going to recompile and then execute. Okay, what is my output? Now you can see the invalid index, right? Rather than what we got here, that is the third element is 7. Now we'll get invalid index. Now the last one was traversing. Traversing is just saying we just need to use the for I in V. So for every element in the vector, just print the element. That is what is happening here. Okay. So that's all about vectors. Now we'll see some of the theoretical part that you have to discuss in the vectors. So I think these stuff are clear. Dynamically growing array, like macro, we have discussed that. Yeah. So now you can read the values from a vector using a pointer. Okay. Now why are you using a pointer? Because you don't want to take the ownership. If you don't want to take the ownership, you can use a pointer. But this is not a much important issue because even if you pass a particular element into the println function, it actually does not take the ownership. The println function only takes the reference of any kind of value. But when you actually move into a particular another variable, okay, you might want to take the reference because it might not have implemented the copy trait. Okay, so you want to access it using the ampersand symbol. Now the confusion, like, you need to use an ampersand symbol before accessing the particular element. So you are taking the reference to that particular element. Okay. And yeah, this was the more safe method that we used was the get function. And with that, you need to match the elements. Okay. So an additional match statement needs to be written in order to create a more safe method to access a element from the vector. So that's all about here. We do not have to take the bounds. there is, yeah. So this is the vec macro, and yeah, so this is an immutable borrow. As you can see, we do not have an and mute. So that means you can only read the value and you cannot change the value. Okay. So what happens is, when you actually take an immutable borrow to a particular variable, let's say I am going to access the first value, and let first is equal to and v0. Okay, now we will discuss some of the theoretical concept. So this is not very important if you are not interested into how these data structures are implemented in memory. But yeah, this could give you more of an idea of how vectors work. So basically, vectors are different from arrays because arrays, they actually require the initial space at compile time. So they have a fixed amount of size and they will fix it. But that is not the case with vectors. The initial setting of vector size would be like 4. And then if the size exceeds 4, it will try the compiler would try to find a particular memory which contains a size of 8, and now it will accommodate the values, and it will take a copy of the values from the previous memory location to the new memory location. Okay, so now we will have a size of 8. Initially we had a size of 4. Now until and unless the size exceeds 8, it will be at this particular location. So if we have a ninth element that is coming to the vector, then it will try to search for a particular location with the size 16, and then it will start accommodating the vector. There is an overhead. Overhead means you will need to copy the elements from the previous location to the new location. Okay, in case of a vector. Now this is the problem. If you are trying to create a reference to the initial value and then you are increasing the vector size, the vector is actually moved from the initial location to a new location in memory, so that your first pointer is still pointing to the initial location, right? Because pointers are address. They are not actually pointing to the particular value. They are actually pointing to the address where it has been stored. But in case of vectors, they will be moved out of that particular memory to some other memory while its size increases. And that is why you if you are taking an immutable borrow, then you might not actually want to change the vector. Okay. Now this is what I have been discussing here. Take your time to read this if possible. So the idea is how we actually copy values from one position to another. Okay. I think there is a copy in each slide. So we discussed the iterating part. And yeah, you can create an and mute v for I in and mute v. So what we are trying to do is we are trying to take a reference of this vector v, and then we are trying to change its value using the star I plus. Now what is star I? Star I means dereferencing. Okay, so that means a reference could be marked by an ampersand sign, whereas a star means dereference. So ampersand is the location of the particular value in memory, whereas star is the value in memory. Okay, so a star actually dereferences an address to its corresponding value. So if you use a star, you can actually change the value, not the address. Now I think you got a pretty much basic or a good idea regarding vectors. So we'll go to the second points regarding vectors. Okay, so I'm launching the second quiz. I think you can see the questions. First question is, which of the following is the safest method to access an element of index 0 from a vector v? Using and v0, using v dot get 0, using v0, none of the above. The second question is, we can use the vec macro to create a vector. The options are true and the option second is false. Okay. So take your time. You'll be given 1 minute and 30 seconds to answer. So I guess the time's up. I'm going to end the poll. Yeah, so the first question was, which of the following is the safest method to access the element of index 0 from a vector V? And oh, so the answer, oh wait, I haven't shared the results. Okay, now I think you guys can see the output. Okay, the right answer is using v dot get 0. So that was the safest method because it has implemented the option in. Now we have state true or false. Yeah, it's a simple question. We can use the vec macro to create a vector. Okay. Now, yeah, now we'll go to string. So most of you would be familiar with string as we had to use string in different locations till now. But yeah, here we will be discussing strings in a much elaborate way. Okay. So what is string? String is basically a collection of characters, right? String is a collection of characters. And if you have used C, then you know that basically a string in C is actually a collection of characters. So it is an array of characters. Okay. Now Rust has two different kinds of strings, and this is very much required for us to understand. It basically uses an AND str and a string data type, where an AND str is basically a string size and it is immutable by default. So when you actually write and assign like let x equal to hello world, then x is basically an AND str and it is not a string. So if you want to create a string data type, then you need to use the method let x equal to string from hello world. Okay, so by default, if you use let x equal to hello world, then you are creating an AND str. Okay, so AND str is like pointer to the particular string or literal. Now these things are actually immutable because you are taking an immutable reference. Now string is a standard library string and it is mutable. It can be pushed, it can be changed, etc. can be done with a string data type. Okay. Now that is it. So let s equal to string from initial content. So you might have been familiar with this command because we have used it in multiple scenarios while working with the previous 3 sessions. Okay, so let is equal to string from initial context. That's it. But when you create a normal string like hello world, let data equal to hello world, what you create is an AND str. But what if you need to convert that AND str to a string data type? So what you use is toString function. So when you use the dot toString function, what are you doing is basically converting an AND str to a string. Okay, I think the idea is clear. So the toString function is used to convert an AND str into a string. Now, see how you can actually update or mutate a particular string. So when you see, we can create a string using let s equal to string from hello world. That's it. So simple. Now you want to update that string. How you can do it? So you can use let mute s equal to string from foo, and then you can do s dot push str bar. So what are you trying to do? You are using a push str function to concatenate the second string into the first string. Okay. Now, if you concentrate, you might see that the bar is actually an AND str by default because we haven't created a string data type, right? What we have used is an AND str. By default, any literal or string is AND str unless we use the toString function or we use a string from in order to convert that particular AND str. Okay. So what happens here is S is the initial string and now we have an AND str bar that is being concatenated to this particular string. And it is evident in the second example where you are actually creating two strings, that is let S1 equal to string from hello and let S2 equal to string from world. So both of them are strings. And in order to actually create a third string, let S3, which is actually a combination of both of these strings, first you need to use the S1 and then you need to take a reference of the second string. And a reference of the second string is actually AND string and it is not AND str. Okay. So these are two different or different terms I'd like to show you some examples so that if there is a confusion, it can be put out. Okay. So this is how we create a normal string, and then this is how we create an AND str. So this is an AND str by default. Now this is how we convert an AND str to a string. So this is an AND str. Okay. Whereas this is a string. As you can see, the data type is already specified. Now this is in order to convert an AND str to a string. Okay. Now this is how we do it. Now, yeah, so this is how we create a string from the function. Now updating here, what we did was we have s2 and we used that s2 to push. So basically this is of the data type and str, because we are directly using the literal. And here what we do is we are trying to pass the AND str using the push str function to actually add it to this s1. So what we will get in s2 is foo bar, because it will be the concatenated value. Whereas here we have a more interesting example. We create a particular tick tag, and then we create another string top. So you might have seen the example here that okay, we use the second string as a reference. So what if you have three strings? So when you have three strings, you will do let s4 is equal to s1 plus s2 plus and s3. Okay. So whenever you want to add more and more strings, you need to add more and more ampersands along with it. Okay, so this is actually a hectic task to do. So what Rust did was it came with a format macro function. So what happens is you can use a format macro in order to concatenate the string to any required type. So that is what we will be using, because that is more easy to use and understand rather than looking up into different pointers. Okay, so since the format macro is much easier to read and the code generated by the format macro uses a reference, so that it is actually not taken the ownership. Okay, we are not passing the ownership because the format macro is basically taking the ownership. So that is the idea. We would wish to use the format macro. Now what would be the output of this string? Because initially it will be s1 followed by a minus and or a dash followed by s2 and again followed by a dash s3. So the required output would be tick dash tag dash top. Okay, we'll see it in a moment. Before getting into that, I would like to add one more thing, that here, although we say that these characters are stored as an array of characters, okay, the vectors, okay, but here usually no, Rust allows you to have any different kind of string. It could be an emoji, it could be of different language. So usually a particular character takes a space of around 2 bytes. Okay, 2 bytes, it will take a space of around 2 bytes, and hence indexing is not permitted in Rust. So that means if you have used strings in particular languages like C++ or Python or JavaScript anywhere, you might know that you can access an individual element of a or individual character from a particular string. So let's say if I have hello world, and if you see the first index would have h, but this is not how characters usually work in Rust. So indexing is not permitted in Rust. Rather we would use slices. So as you can see here, I am going to take a slice from 0 to 4. That means it will allow me to get the values from index 0 to 3. But now you can see when I execute this output, you see initially what is in our mind. Our mind, we will have like 0, 1, 2, 3, right? So the first four characters, that is 3, and this one, I don't know what characters this is. Then you have P and then A. But that is not how Rust actually stores these characters. So Rust actually stores these at in an ANSI or UTF-8 coding format. So each character is then placed into its corresponding number. So you cannot use uh, indexing to access each of this, but rather you can use a particular slicing. So slicing, usually what happens is when you want to take a slice, you need to take a reference to the particular substring. Okay. Now we'll see the output right now so that it is more easy. Rust C strings. There is no error. Yeah. So guys, initially what we did, we will just go in that particular order. So what we did was we created a string and we used the print around here because S2. So S2 was bar and that was what we did here. Okay. And if you want to print S1, so we'll just do S1 is, and so after concatenation, what happens? That is something that we want to see, right? Yeah. So S1 is foo bar. Okay. So S1 was foo and S2 was bar. Now we concatenated both of them to get foo bar. Now in the second example, as you can see, I have tried to take, say I have tried to take the 0 to 4, 0 to 3 index. Okay. From 0 to 3, I want that particular substring from the string hello that is equal to this string. Okay. Now what I got was the first two characters. Why? Because Rust actually uses UTF-8 encoding and we will save it as an array or a vector of different integers that actually represents each character. Okay. So that is why when you try to access elements in this kind of strings, what you might get is a different set of values. Okay. Now, what you can do is again, we can see the different characters present in this particular and str. That is by using dot chars, and then when you try to print each character, you can try like we have 3 and this particular symbol. So the two characters will be 3 and that particular symbol. Now the interesting part is for B in 3 this dot bytes. So this is characters and characters are actually stored in memory as bytes. Now if you see the different byte values are 208, 151, 208 and 180. So the first two numbers are then used to actually represent 3. The second two only used to represent the second one. Okay. So it requires 4 numbers in order to store these two characters in memory. And that is why when I try to access the first 4 uh, indexes from the particular string, that is from 0 to 4, I have 0, 1, 2, 3. What are those? In memory, these numbers are what we get. So that is 208, 151, 208 and 180. And these numbers by default represents these characters. Okay. And that is why we get this 3 and this particular symbol when we try to access the 0 to 4 substring from the particular string. Okay, it is a bit more complex to understand because it is not the traditional approach of getting particular index or substring from a given string. Okay, it is a different approach. And yes. So the format macro is one of the easiest method that you can use in order to actually work with concatenation of strings rather than putting yourself in the doubt of creating different pointers to strings. Okay. Now, indexing. So Rust does not allow us to index a string because a character that indexing operations are expected to always take a constant time of 1. But it is not possible to guarantee the performance with a string because Rust would have to walk through the contents from the beginning to the index of the determine how many valid characters were actually seen. And we have discussed this. We need to use a slicing in order to take that. And when you use the slicing, what you get is a different string. Okay. Now, we will go to the quiz time regarding strings. Strings were also one of the easiest topics that we can discuss. The next topic would be hash map. And then we'll see the errors. So I'm launching the third quiz for today, and that is strings. I think you can see the question. So the first question was Rust has how many types of string? Okay. The options are 1, 2, 3, and 4. The second question is, which of the following function can convert an AND str to string? Okay, the options are to str, to string, push, and none of the above. Guys, don't actually put the first option because I think it should be a typo error from our side. Okay, so don't answer the first option. It's by default wrong, you might know it. Okay, to str, to string, push, and none of the above. So I guess the time's up and I'm closing it on here. Yeah, the first question was Rust has how many types of strings? And I didn't share the result. Okay. The answer is 2, because Rust has 2 types of strings, the AND str and the string. Which of the following function can convert an AND str to a string? And the answer is this toString function. Okay. So I think 58% got it right. Great. Now we'll go to hash maps. So I don't know how many of you are familiar with hash maps already, but if not, this would be one of the best moments for you to learn hash map. So consider an array. Okay. So in order to check whether a particular element X is present in the array, you need to traverse through the array at least one time, right? The time complexity to do such a task is usually O of n for linear search. Now, can we do better? Yeah, we can. So that is where we actually use a hash map. Now, what is a hash map? So hash map actually uses a function called hash function in order to return the index of an integer if passed the integer. That the consideration would be like this. I'll show you a simple demonstration. So you don't want to look at this code, okay? I just want to show you. What if I use a hash function f of x such that I would always take x percentage 10, okay? And I need to pass the element 1, okay? And I need to pass the element 2, 3, 4, and 5. So the basic idea is when I pass 1 percentage 10 will give me what output? It will give me 1. And 2 percentage 10 will give me what output? It will give me 2. 3 percentage 10 will give me an output 3. And 4 percentage 10 will give me an output 4. So the idea is whenever I pass the element, I can get its particular index. So let's say my array is just this one, that is 1, 2, 3, 4, and 5. Then I can convert my hash function to x percentage 10 minus 1. So what if I pass the element 2? So when I pass the element 2, I have 2 percentage 10, which is equal to 2. Because the remainder when you divide 2 by 10 would be 2, right? And now 2 minus 1 is the index of 2 in this particular array, right? Because 2 is in the corresponding location of like the initial 0 and then 1, then 2, 3, and then 4. So 2 is against the index 1, right? So this should be index and this would be array. So 2 is against the index 1. So whenever I pass 2 in the function, I'll get 1 as the value. So what happens? Now I can check whether a particular element is in the list or not by having a complexity O of 1. That means just by knowing the value, I can check whether it is actually present in the list or not. Okay. If present, then what is its index? Okay. So that is the use of a hash map, and that is very important for us because whenever we want to reduce the access times, the data structure of our consideration would be hash map because it is really useful. Okay. So yeah, hash map is usually a combination of key and value, where key would be the particular kind of element that we need to search in the list or we need to find the index of, and V would be the particular index that we get. Now it is not limited to the case of key value considerations for the accessing element from an array. There could be different scenarios where we want to actually map particular things to a particular. For example, uh, your Aadhaar number against your name. Okay. So what if when I pass your particular Aadhaar number, I would get your name. So these are different things that I can do with the hash map. Okay, wait, what happened? Yeah. So which determines how it places the keys and values into memory. Hash maps are useful when you want to look up data, not by using an index as you do with vectors, but by using a key that can be of any type. Okay. Now see the example so that it will be more clear. I think this is hash maps. Yeah. So how to actually, so in order to get a hash map, you need to use this use command is similar to hash include in C or C++, and it's similar to import in Python or require in JavaScript, anything. So what we use this particular keyword is to get the required amount of library or the particular class or any kind of function that we need to use at this particular current program. Okay, so I require the hash map from the standard collections library. Okay, and that is why I use standard collections hash map. And then I have a main function where I create a new hash map similar to creating a new vector or a string. You just need to place hash map colon new. It means you create a new hash map. Now you need to place it as mute so that we need to insert values into the hash map. Now see, I am going to insert using the insert function. So dot insert string from blue to 10. So what happens is my key is blue and the value corresponding to blue is 10. Okay. Now scores dot insert string from yellow 50. That means my key is yellow and my value is 50. So whenever I try to access the element, like say I want to know what is the value. So print ln. I'll just show you that example only. So okay. So println, we'll just add one more element. Okay. So scores dot insert string from say red, and let's give 100. Okay. Now I want to access the value corresponding to yellow. So how can I do it? I can do println the value corresponding to yellow is scores. Okay. Scores dot get yellow. Okay. Now the problem is usually when you use the get, okay, when you use the get, what happens is you would have a sum and none option that as you can see here. When you try to use the get, you will need to match it against a sum x and none x in order to actually define the kind of output that you need to get. So yeah, we will see what is the output in this kind of a scenario. Okay. Wait. Yeah, so you can see the error would be option integer cannot be formatted with a default formatter. So what we need to do in such a scenario is to use a match operation. Okay. So use a match operation. So how to do that? The basic idea would be let yellow is equal to match scores dot get yellow. So what I'm doing is I'm using the match scores dot get with the particular yellow value, and if sum of x existed, then I need to return my x. What if none? Okay, if it is a none, then I can return a -1. So I'm returning a -1 instead. Okay, now these both things are integers. Okay, we need to make sure that the data type that you return in both the cases are same. Now I can use this in order to print ln yellow value. Yellow's value is again pass yellow. Okay, now try execute because there, yeah, wait, in line number 13 I have induced a semicolon. Okay, now it's executable. Yeah, so you can see the LO's value is 50, and that was the corresponding value against the hash map. Okay, so now we actually can access the corresponding value to the given key having the least time complexity, and that is the use case of a hash map. Okay, but whenever we use the get function, we need to actually use write a match in order to solve the issue. Okay, now there is something called as overwriting. Okay, what is overwriting? Overwriting means if I am going to change, like let's say, so you know the value of LO is 50 right now, right? Now I'm going to just insert a new value, let's say 150. Okay. Now what do you think? Whenever I try to return the output using this println, what would I get? Would I get 50 or would I get 150? Okay, it is always the latest value that we get because the new value is inserted by replacing the previous value. So whenever now I try to return, I can see the LO's value is 150 because the previous value has been replaced by the new value in the hash map. Okay, so that is the idea about using hash maps. Now you can also print the entire hash map by using this println, but make sure you use the debug operator. Okay, so debug operator is very much important for us in order to print the entire hash map. So you can see this is how the hash map stores. It's similar to a JSON file where you can have a particular value against or key against its value, key against its value, key against, similar to JSON. Okay, and how can you actually pass through each and every character, sorry, each and every element, key and value pair? You can also use the for key value, which is a tuple representing key as the initial value and value as the next one. Okay, so key value in and scores. Now why are you using the and scores? Because you only want to take a reference. So you just need to print ln key and value. Now this actually enumerates the entire hash map into a set of key value pairs, which is actually a list of tuples. The first one, the first index in the tuple would be representing the key, and the second one would be representing the value. I think the idea is clear. This is how we work with hash maps in general. Okay, so this is how we create a new hash map. We can insert value and we can access a particular value using the get function, and you need to match it so that you can have two different considerations, that is the sum and the none, because sometimes you are trying to access a color like say white, but white is actually not present in the hash map, right? So in this kind of a scenario, usually you would be prompted up by an error, right? So you can actually consider that scenario by using the none. Now you can have println to take a particular value, or even the entire hash map can be printed using the debug operator. And you can also print each and every value or the key value pairs using this methodology, that is an ampersand scores, which takes a reference to the particular hash map, and then we will print it. Okay, I think the idea is clear. go back to the slides. So that is what we have for in hash maps. Okay. We'll discuss this as well. Overwriting was also discussed. Yeah, that is okay. So we'll go to the hash maps quiz. Okay. And I'm launching the quiz. Please feel free to answer, and you'll be given 1 minute and 30 seconds to answer. Okay. The search time when we use a hash map is what? It is of 1, it is of n, it is of log n, and it is of n log n. Okay. And which of the following functions is used to add a new key value pair to the hash map? The options are push, insert, toString, and none of the above. Okay, so these are two easy questions. Sometimes you might be confusing the first question, but make sure you got the idea of the least time complexity with hash map. Okay. And the second question is pretty much straightforward. Yeah. So I think the time's up. I'm closing the poll. I'll share the results with you. Think you can see the results. First question was the search time when we use a hash map is 43% got it right. It's O of 1 is the least time complexity that you can get for an accessing or any kind of operation in a program. Second question was which of the following function is used to add a new key value pair to the hash map? And yeah, it was a pretty straightforward question. You might have seen the example right before. So the answer is insert. Okay. Yeah, 73% got it right. And we'll go to the continue. Yeah. So now we will start discussing what is error handling and what are the different error handling measures that Rust actually takes into consideration. The first thing about errors is whenever, what is an error? So basically error is something that we do not expect to happen during a execution of a program or a production level software. Now, there are two different kinds of errors. Errors that usually come up at compilation time and errors that usually come up at execution time. The second one is the most dangerous because most people want to get errors during compilation time so that they can fix it on development and not in production. Okay, so there are multiple ways to actually analyze where errors do occur, and this process is called as debugging. You might have gone through this phase if you have an experience with coding, or if you have started programming using Rust right now, then you'd be having an experience in debugging or fixing errors because mostly they occur while you code. And yeah, so Rust has a number of features for handling such situations. And Rust groups errors into two main categories, that is recoverable and unrecoverable errors. It's not only Rust, you have a standard level of languages which actually divides errors into recoverable and unrecoverable. A good example would be Java. Now, Rust doesn't have exceptions. Instead, it uses the type result. So here, what we use, you might have seen exceptions in Java or different kinds of languages usually have different methodologies, an exception, a throw error, etc. But in Rust, what we use is a result type. Similar to, its result is actually similar to an option, enum. Okay, similar to the option enum. It is also an enum by default. So yeah, for recoverable errors, that is what we use, and it's one of the safest method to actually return values from a function or a particular variable. And the panic macro is used that stops the execution whenever a program encounters an unrecoverable error. Okay, we'll see it. Now, the unrecoverable error means Rust uses a panic macro in such kind of a situations. Now, an unrecoverable error usually halts the current execution of the program, and it would obviously show you an error like thread main panicked at this particular location, and it will also show you the error message that has been specified by the Rust library or the compiler. Now, you can generate a panic by using two methods. So we usually do not want to generate a panic, but yeah, there are two methods to actually generate a panic. And the first one is to use a panic macro. So whenever you use a panic macro, what happens is the program will panic. Okay. Now this is mainly used during development in order to identify or study certain particular areas of code. But by default, the panic is called when you try to do something which is invalid. For example, I have created a vector with 1, 2, 3 as the elements. Now the size of the vector would be 3. And I'm trying to access an element V99. That is the 99th element, which is actually an invalid access. So during an invalid access, Rust generates a panic backtrace or a panic function call. Okay. So that is the idea. So simple. Like, we do not have to go to the IDE because it's all that has been present in here. That is, you can use a panic macro directly in order to generate a panic and halt the execution, or there could be scenarios that automatically generates the panic macro or the panic backtrace, and such things are the invalid accessing. Okay, this is pretty much provided. Now we'll go to the recoverable errors. So recoverable errors are those errors which we can handle during compilation time, or we can actually continue the execution even with this. It's because we can recover from the errors. Now we use a result for these kind of errors. And for example, when we try to open a file which is actually not present, then the program would generate a panic. Okay. Now in such scenarios, what we use is the enum result, and enum result would generate a positive response if it is an okay, or it generates an error if a particular kind of error occurs during the operation. Okay. And yeah, in the case of a success, anything that is present inside the OK variant will be executed. And in case of an error, anything that is present inside the error would be displayed. Okay, it's similar to the option data type where you have a sum and none. But option data types are usually limited to accessing elements, because it is like whether you have an element or you do not have an element. But a result type can be extended to different scenarios where you might occur with an error, like opening a file, etc. Now, as you can see, I'm trying to open a file here in the main function. I'm trying to open a file, that is file open hello.txt. So when I'm trying to open a file, what if that file does not exist? If the file does not exist, then I need to control such kind of a scenario by using a result data type. How will I do it? Basically, what I do is let greeting file is equal to match greeting file result. So I'm matching the initial variable against this value so that it returns the file if it is an okay. That means if the file is already present in my directory, then it would generate the pointer to that and give it in let greeting file. If not, then it would generate an error and it would print like problem opening the file, and it would print the error as well. Okay, we'll see an demo so that the idea is clear. I think the error should be, yeah, we will see the example. So see, the panic was simple. What I tried to do was just add this into a main function. You can try to deduce what would be the output. Like it would like, okay, we'll just go to execute, so it would be yeah, you can see, right? thread main panic that crash and burn. So anything that you type inside the panic macro would be seen as a error message. Now I just stop this and we will try compiling. I will try executing. So now you can see thread main panicked at index out of bounds. Now this is a by default error in Rust that when you try to access a particular element which is out of the bounds. Okay. The len is 3 and the index is 99. So it gives you some more information regarding what is happening with your code. So that was the idea regarding the panic. Yeah, with result, what happens is you require the standard FS file in order to actually open a file. Now you try to open this file and that is what you write. And you want to match this particular result, that is what the greeting file result gets into the OK file. So what we use is match this against a result data type. So the basic type that the greeting file right now has is a result data type. So it would be of the type result. Okay, it would be of the type result. And if it is an OK, then it would get a file, or it could be like a pointer to some file, right? And if it is an error, then it could get an IO error. Okay, so that is the idea. So we might get a string or we might get a error. So this will be the type of this particular variable. Okay, but it would be like obviously understood by dynamic data type setting. So what you need to do is match this output, that is the particular value that is here, and to OK and error. So in an OK file, it will return the pointer to the file, or in an error, what it would do is it would generate a panic macro to actually end the execution and show the panic. Now, yeah, you can use another method, that is the expect. So you have used this expect in different scenarios, like the accessing a string from the user. Now, this is considered as one of the safest method to actually do the operation rather than having this much amount of work. So it's very easy to do. Just open a file using file open and then use a dot expect. So dot expect means expect an error. If there is an error, then stop the execution and show this error. Else, you want to continue the execution. So dot expect is one of the easiest methods to actually get the value if it is valid. Okay. So that is the idea of a result type and expect. Now, we also have one more thing, that is we also have two more things to discuss. And the other important factor that we would want to discuss is the I just want you to concentrate on to this function. This function reads the username from the file and it generates a result data type. The result will generate a string if there is no error, or else it will generate an IO error. So the first thing that we will take is let mute username as string new, and file is opened. We are trying to open this file, and then we will call this function read to string and mute username. Okay. Now what are we trying to do? So we are trying to read to string this particular value, and if there is an error, so this question mark means it's automatically calling the OK and the error case. So if there is no error, then the OK username would be returned, and if there is an error, then the IO error would be produced. Okay, so that is why we use a question mark. The question mark at any point refers to if it goes well, then return the OK username, or else return the IO error. So it is one more easier or simplest implementation of the match operation for the result data type. Okay. So for the match operation for the result type. So the result type, if it works well, then it can return the OK username, and that is why we place it here, because it would be what it's returned. Now, if it is not, then it will return the IO error. Now, IO error is by default present in the standard library, so it would generate the particular error message as well. Okay. So, similar or easier implementation would be this. We try to open, or we try to fs.read to string this particular file, and if it goes well, then it will get a string, or else we will get an error. Okay, so that is the basic idea to work with errors. We can have a result data type by using OK and error, or we can use an expect, or we can use a question mark. Question mark is just same as result function, just we can reduce the number of steps. Now sometimes we need not have to use the question mark also, we can just specify it in the output, so that anything that this thing, now we are trying to return this, right? So read to string, now we want to try to opening this file hello.txt. Now if it goes well, then it will return the string, or else it will return the IO error. So this fs read to string basically trying to do the open a particular file with the name hello.txt. Think the idea is clear? Okay, go back to the recoverable errors section. Yeah, so this was the idea. We tried to match it using the OK and the ERR options. And now there is something called as unwrap. Okay, we have not discussed unwrap till now, but I have discussed the expect with you guys. Now, why did I discuss unwrap? Because unwrap is not very safe to be used. Now, unwrap is similar to expect. So rather than the expect, you can use the unwrap. Just use dot unwrap and do not place anything. Now, unwrap can or cannot panic. So if there is a value, then unwrap would actually open the value and would give to you. But what if there is no value? Then you should try to open none or the no value, and then it would panic. So unwrap would panic at any point of situation, and that is why it is more advised to use the expect, so that we know where the error occurs, why the error occurs, and what is the kind of error that we are facing. Okay, so the result value is OK, then the unwrap will return the value inside the OK, and if the result is an error, then it will call the panic macro. Okay, so that is how we use it. It's so simple, but you just need to place dot unwrap to the operation that you think would generate an error. Now, the expect is the safest method that you can use till now, because it will generate the kind of error message that we want to get. And yeah, using expect instead of unwrap provides good error messages and can convey your intent, make tracking down the source of panic easier, and also it can give the required information like the line number, what kind of error it is, and what could be the reason of this error. Okay, so expect gives you more operational benefits compared to unwrap. So try to use expect than unwrap in every case. Now that is the idea. Now unwrap, yeah, this is what I was mentioning. Most frustrations choose expect rather than unwrap and give more context, because why the operations is expect not to always succeed. Now propagating errors. So this is something we have seen in here. Yeah, using the question mark. So what the question mark does is, if the value of the result is an OK, then the value inside the OK will get returned from this expression, and the program will continue. If the value is an error, then the error will be returned from the old function, as we had used the return keyword. So the error value gets propagated to the calling code. Now propagating error means when you call an additional function, you want to propagate that error from this particular function to the main function, so that we can stop the execution of the main function. That is what we do here. We try to return a result type which could be a string if everything goes well, or else it would be an error. So whenever we get a particular error in the given function, it would be propagated or passed into the main function, which in turn halts the execution of the main function. So this is how you do it. You need to give a return type of result with the OK value and the error value. Okay, so when you use a question mark, it checks if this thing panics, then it would give an error, or else it would give the OK value. I think the idea is clear. Now, custom type. So custom type, whenever we come across different kinds of errors and expectations, the basic idea is to like create our own custom validation. Now, this could be like setting age limits or any kind of required limits that we need to keep while working with our program. So let's say you create struct guess, which is having a value I32, and you are implementing this guess to have a function new. So this new function is actually different from other functions. As you might know, the new function is used to create a instant or an object of the particular struct. So this new function is different from any other function that you write in the IMPL. The difference is similar to the def init in Python, or it is similar to the constructor in C++. So the idea is the constructor is what we see as the new function in here, because whenever you see hash map not new, it creates a new object of the hash map type. So this is how we actually do it. We need to implement the new function. So what happens? The value is less than 1 or the value is greater than 100, then panic. That means the value must be between 1 and 100. If it goes well, then you can generate an output that is the guess value. Now, what is guess value? It is actually a struct which contains a value between 1 and 100, right? So if the value is greater than 100 or less than 1, so the value that you guessed is actually in between this value, then it would generate a panic. Okay, so it shouldn't be less or it shouldn't be great, it should be between 1 and 100. Then we could get a required return type, that is the guess value, where guess would be the struct and the value would be the value that is being present. So the consideration or the exception or the kind of validation that we put forward is that the value should be between these given ranges. Okay. So this is a how to create a custom validation. So what happens is whenever I try to create a new instance of the type guess, okay, the value that I pass into the guess, if it is actually not in between 1 and 100, then by default it would generate an error. Okay, so that is what happens here. Okay, I think the idea is clear. So we try to create a struct, and I think we can show the output. Okay, might want to copy this code. Okay, so we have implemented two functions, and we will go to fn main and let x equal to guess new. Let's pass 10. Okay, now let us run. So Rust C practice. Oh, wait. Yeah, so now we can execute. Yeah, so as you can see that there is no error, right? We'll try with minus 100. It should probably generate an error. Yeah, you can see, right? Thread main panic that guess value must be between 1 and 100. So it got minus 100, and that is why it has stopped the execution. So this is how you create your own errors, or this is how you create your own validation. So now the value that I passed into the guess new, if it is actually not in between 1 and 100, then it would generate a panic. It's very easy to generate these kinds of validation. Okay, so I think the idea is clear. So we define a struct, the code in the new body checks if it is between 1 and 100, else it returns. We'll go to the last quiz time for today's session, and that is regarding the errors. I'm launching the quiz. We're given 1 minute and 30 seconds to answer. I'll just read the questions for you. The first question is state true or false. Expect gives more information than unwrap, and hence it is more preferred over unwrap by most crustaceans. The options are true and false. And the second question is state true or false. We use a result to handle recoverable error situations. Okay. See, the options are true and false. Yeah. Please feel free to answer. You'll be given 1 minute and 30 seconds to do so. Yes, the time's up. So I'm stopping the polls. I'll share the results with you. First question was expect gives more information than unwrap, hence it is more preferred over unwrap. The answer is true. 76% got it right. The second question was we use result to handle recoverable error situations. Okay, the answer is true and a 78% got it right. Nice. Okay, great. So I think that's all for today. In today's session, we have discussed about collections. We have discussed different collections include vector, string, and hash map. There is actually a lot of collections like B-tree map, etc., etc., etc. So if you are interested, please go and deep dive into these kinds of data structures that are present in Rust. Please refer the Rust book in order to get much more information regarding these data structures, because it might be useful for you in the long term. And also we discussed regarding the different error solving conditions. Okay, so that's all for today, guys. I think I'll pass to Deepak Singh right.
Hey, Rishan, thank you so much. Uh, just loved how this session has progressed and it was really wonderful. Thanks once again. So, guys, before you leave, let me just do a quick feedback poll here. So, you'll see the questions on your screen. Please give your ratings, uh, describe, and I mean, you also have the option to describe if you have any suggestions for us. So, please take a minute and let's do that. And I'll be sharing with you the links of quiz and the assignment. But while I share the links, I want to suggest that go and use the platform because on the platform you'll find the PPTs, you'll find the videos to previous sessions and a lot of other resources in the learn section as well. So platform is going to be very handy for you. So just make sure that you go and utilize our platform for yourselves. All right, let me just paste uh, the quiz and the assignment link for today. Yeah, so the links have been pasted in the chat box. Please refer to them. I'll keep the poll open, the feedback poll open for another minute or so. While we do that, let me just go to Praveen sir and see if he has any inputs for today's sessions and any suggestions to the students. Praveen sir.
Thank you, Deepak, and thank you, Rishin. Thank you so much. I think I always love what when Rishin talks. I am hoping that these sessions are helping you appreciate Rust. Now, again, I'll go back to my previous point that it is a little complex topic, and if you are not really completely following it, so don't worry. It will happen, but then it is important for you to be consistent. While we do that, I think I'll also with Deepak Singh, being around here, I just wanted to say that while we are taking your Rishan is helping you understand Rust. We will be also getting into module 3 very soon in a week's time or so. And in those, in that module, you will be kind of experiencing the real code built in Rust and Substrate. So I think it is advised that as much as you can understand, Rust right now, that will be helpful in future building process, right? So hang tight, and I think you will be there. So yeah, and I think people who have been consistent so far, that's one thing that Deepak, I wanted to mention, that people who have been consistent so far, I think it's many congratulations on that. Because I see some people not joining consistently, and the effect is going to be disastrous for them. So I think if you have been here consistently, many congratulations. In between, if you have missed some sessions, then like Deepak mentioned, please visit the website portal ibc.media, and there you will be, once you log in, you will be able to see all those previous sessions there. Okay. So if you have missed something out, please do that. Go and listen to them. Even if you have done that live class, and if you want to revisit something, please go and do that, right? So all these things are important, for next 1 week or so. Yeah, thanks, Deepak.
Yep, absolutely. Thank you so much, sir. Yeah, so guys, just so you know that as always, I mean, it's the same information, but let me say it once again. The quiz will be open till midnight today, and the assignment will be open until the start of next session, which is day after tomorrow. So yeah, make sure that you finish them within their respective timelines. I see a lot of people asking, I won't say a lot, a couple of them who ask us to, put on the quiz and assignment way mm, way into the session. uh, I mean, in the next session that begins. So please don't do that. I mean, we won't be able to give any exclusive accesses to anybody. It's the same rule for everyone. If you have not been able to do it for some reason, I mean, it's all right. But just try to do it, because quiz will take somewhere around 2 or 3 minutes. Assignment will take a little bit more time. So I think overall it takes somewhere around 30 minutes to or 1 hour. So I think it's manageable. So try to prioritize and try to complete it within the timeline. And I'll be also sharing the links in the WhatsApp group. So yeah, feel free to check it from there as well. Let me see how many of you have responded to the questions. Okay, 66% of you have participated. Guys, I request everyone to just submit your responses in the feedback poll. It's always better to check from you what your experience has been, and if there's anything that you want us to work on, we'll definitely have a review and then get back on an update according to the same. And yeah, so a quick reminder on the rewards at the end of module 2, based on your responses in the poll, your quiz, your assignment, your attendance, we have some really exciting rewards for the people who have participated. Uh, and most of you will be getting it provided you adhere to these rules that we are pushing in, where you have to participate in the polls, try to get best answers, try to be accurate, try to focus on the sessions, be attentive, be interactive. Interaction is also one very important element in this process. I mean, we do the ratings of how people are interacting during the session, be it in form of question and answers or whatever that may be. So yeah, all of these things carry certain amount of weightage. So please make sure that you do that. And obviously, when the certification process begins, we all of these things are taken very seriously. All of these things are monitored, and on based on these factors, we decide who will get the merit certificate, who will get the rank holder certificate, who will get the merit certificate, who will get the education certificate, and who will get the participation certificate. All right, so let me just check. Okay, okay, some of you are still answering, so let me just keep it open for another 2 minutes. If you have any questions, please put it in the chat box. Okay, can I do assignment till next session? So the question is from Anjali. Yeah, Anjali, you can do that, but make sure that you do it before the start of the next session. All right, let me see if we have any other questions. No. Okay, guys, so last minute to submit your feedback. Please go in the poll section. If it's not open in front of you when you see the feedback option, just submit your answers over there. We'll wait 30 more seconds. If you have answered the poll, feel free to go and start working on your quizzes and submit them on time, please. Okay, so can you please share quiz link again? Yeah, absolutely. Let me share it once again with all quiz and assignment link. Right. Yep, done. Mm, right, that's addressed. Yeah, so guys, once again, thank you so much for joining in. It shows a lot of effort from your end when you come after a day's work at your college, or you might be working, or whatever your current status of work would be. It takes a lot of effort because 1.5 hour session is not a cakewalk, especially when we dive so much deep into some technicalities like Rust, which you may not be so handy with, but yeah, learning is the best part of this entire process, and that's why we are here. Remember, the end product is for us to really just adopt blockchain and come and build something brilliant that will surprise this entire world and obviously the blockchain industry. Once again, thank you everyone. Thank you, Praveen sir, for taking all the time. Thanks, Rashin, for yet another wonderful session. Thanks to my entire team working at the back end to make this entire event possible. See you guys very soon. Next session is on 23rd, same time. Just remember that you submit your quizzes, submit your assignment on time, and the links have been pasted in the WhatsApp group as well. Okay, guys, have a great night. See you all very soon. Thanks a lot. Thank you so much. Have a good day.